Hi and welcome to Math for All. In today's lesson, we're going to be looking at another method of solving linear systems or equations. In this case, instead of graphing, we're going to be looking at the method of substitution. In this method, we have to realize that whenever we're talking about two different lines that have different slopes, they will always find a place to meet. And so one of the ways of solving this is by substituting for one of the variables. The reason we do this is because we have an x and a y. If we have two unknowns, there's absolutely no way that we can figure out what that unknown is unless we eliminate it. And so what we're going to try is we're going to try and eliminate x or y. This is actually a nice example. It makes it easier for us to understand. It automatically tells us that y is equal to 3x minus 4. That's what y is. It can be any number. In this case, it's this equation. So what we can do is we can take this information and we can plug it in or substitute it in for the letter y in our second equation. Because remember, it's going to be the same point of intersection for both lines. So that's the reason we can take this and fill it in. Let's see what we get. We're going to get x plus, and then we're going to copy everything that's going to be here. So we can actually introduce these brackets and we can write that in. So instead of y, we're going to write 3x minus 4, close bracket, equals 8. Now, because of the plus sign, all we have to do is we have to simply open up the brackets and copy our answer. Okay, if it was minus, the numbers inside would change. Not the numbers, but the signs would change. We'll do a different example later. So x plus 3x gives us 4x minus 4 equals 8. We always like to have an unknown, a variable, and numbers on the opposite sides. And we try to separate them. This way we can solve for x. So 4x will stay on the left side of the equal sign, and the negative 4 will travel towards the right side. This way we can actually solve for x. So when negative crosses an equal sign, it becomes positive. So we have 8 plus 4. So 4x is equal to 12. How do we solve for x? We have to perform an opposite function. And so 4x is actually 4 times x. So in order to solve for x, 4 times what is 12? Well, the answer is 12 divided by 4. So x is equal to 12 divided by 4, which is the same as 3. We can check our answer as well. We can plug this in for x, and we can see that 4 times 3, which is 12, 12 minus 4 is 8, so we know our answer is correct. The problem is that when we're solving for a point of intersection, not only do we need a horizontal position, we're also looking for a vertical position, which is the letter y. So now we can take this, and guess what? We can plug this, because it's the point of intersection for both lines. We can take this coordinate and apply it to either one of those lines, and your answer will still be correct. So take the 3 and plug it into whichever equation you feel is easiest to solve. In my case, I think I'd go with the second one. So instead of x plus y equals 8, we're going to write 3 plus y equals 8. And once again, in this case, we only have one unknown to solve for. That's why it makes it so much easier to solve for a single unknown versus something that's virtually impossible when we have two unknowns. Now we have an unknown y on the one side. We like to keep our letters and numbers separate, so we'll take the number 3 and kind of move it over towards the right side of the equation. When it shifts towards the right side, its sign will change from positive to negative, and we'll have 8 minus 3. So y is equal to 5. The only way for us to know if this answer is correct is by plugging both of these into both of these equations. So if we were to plug it into our first equation, instead of y, we can say 5. So 5 must equal to all of this, provided that x is 3. Let's see if it's correct. 3 times 3 is 9. 9 minus 4 is 5. So that answer is correct. Let's see if it actually works in our second equation. X, which is 3, plus y, which is 5. 3 plus 5 is 8. So we know automatically that our answer is correct. Don't forget to write your final answer in this form. Okay, in this example, we have two equations, and we're going to do the same thing. We're going to use the method of substitution to plug in, or rather to eliminate, one of the unknown variables. So once again, it's very easy to go with what we already have. Here, our first equation says that y equals, so we don't have to play around with numbers or letters in terms of rearranging them to say y equals or x equals. This already tells us a part of the answer. So we're going to take this information and we'll plug it into our second equation. But it's going to look different than our first example. So let's look at this. It says x minus y, x minus, and then we open up the brackets. So keep in mind that the negative stays, and then we worry about plugging all of this in the way it's written up here. So we're going to say negative x plus 8, close bracket, equals 4. Okay? Now, there is a negative outside the bracket. What does it do? This negative is in fact a negative 1. Negative 1 times everything that's found inside the bracket. You can do it in one of two ways. If you do choose to use the number 1, or negative 1, you're going to take this number and multiply it by everything inside that bracket. Negative times negative gives us a positive answer. Negative times positive gives us a negative answer. Okay, and everything else stays the same. Or if you don't use a negative 1, you just keep in mind that whatever was negative becomes positive, and whatever was positive becomes negative. Either way, you can do it in one of these two ways. So, x plus x is equal to 2x minus 8 equals 4. Letters stay on the left, or on one of the sides, and numbers will stay on the opposite side. In this case, our letters happen to be on the left side, so we'll keep 2x on the left, and the negative 8 must go. So it's actually going to go over to the right side and switch its sign from negative to positive. So the 4 stays, and it's going to be 4 plus 8. 4 plus 8 is 12. I'm going to write it over here. So 2x is equal to 12. How do we solve for x? Basically tells us that 2 times what is 12. So what would that x be equal to? An unknown? Well, if we divide both sides by 2, we'll get our answer. We must always do the opposite of what's written. If it's multiplication, we divide. If we were dividing, we would multiply. If we were subtracting, we would add. Okay, so in this case, we've divided and we got the answer 6. This is only for the horizontal position. Now we have to worry about the vertical position. Again, because lines cross, and this point, the point of intersection, applies to both of these lines, it means that we can actually take our horizontal position, which is 6, and apply it to any of these two equations. Let's see what happens. So usually we can pick the easiest one to work with, And let's go with our first one. It says y equals, it says negative x plus 8. So the negative stays, but it tells us that x is 6. So instead of x, we're going to put 6 plus 8. So y is equal to negative 6 plus 8 is the same as 8 minus 6, which gives us 2. Okay, let's check our answer. So we have this answer for a horizontal position and this answer for a vertical position. If x is 6 and y is 2, 6 minus 2, the answer is 4. That's also correct. We have already done it for our first one. So we know our answer is correct. So the point of intersection must be written in brackets in this form: 6, comma, 2. Alright, so looking at the following examples, you might say, what an awful question. How do I solve this? Because it doesn't say y equals or x equals. Well, you got to do a little bit of thinking in this case. So we have to make the proper rearrangements ourselves. We can pick any of these two equations and we can say either x equals or y equals. Because there's a number in front of x, maybe that's not a number that we want to deal with, or a variable, I should say. So y does not have any numbers in front of it. Okay, so keeping equation written in the same form, we can say 2x minus 5 is equal to y. So the 5 traveled across towards the left. We can also write it, if it's easier for you to see it in this way, we can write y equals 2x minus 5. Nothing changed, except we're just saying it from left to right. If this is what y is equal to, we can take all of that information that we have, we can take our equation, and we can now plug it in for y into the second equation. Okay, what do we get? We have 3x plus, so the plus stays, open bracket, and copy all of this down. We're going to put 2x minus 5, close bracket, equals negative 9. Okay, it is a plus sign, which is great, because all we need to do is now drop those brackets. We get 3x plus 2x minus 5 equals to negative 9. 3x plus 2x, how many x's do we have? We have 5x. Minus 5 equals to negative 9. We don't want this number, it's a negative number. It travels across the equal sign, it becomes positive. 5x is equal to negative 9 plus 5. Okay. Next. So now we have 5x equals to, what's negative 9 plus 5? Question is, how do we do it? It's the same as 5 minus 9, if it's easier for you to think of it this way. Or, when dealing with negative numbers, just think of negative becoming more positive. So for example, if you were underground on the negative 9th floor, and then you're coming up 5 floors, what floor would you be on? You'd be on the negative 4th floor. Okay? So, we're going to get a fractional answer. By the looks of it, we still have to get rid of this 5, and it's not going to be an even division. It says 5 times what gives us negative 4. So we have to keep in mind or remember that we have to do the opposite operation. We're going to divide both sides by 5, get rid of this 5 in front of x, and our answer will be a negative, not only a negative, but also a fraction. Yeah, which, let's see. I need more space, guys. So we're going to take this and we're going to plug it into an equation that fits best. Let's try plug it into our first equation. The numbers are a little bit lower. We have mostly positive numbers. It will probably work out a little bit better. So instead of x, we're going to plug in negative 4 over 5. 2 times negative 4 over 5 equals to y plus 5. Okay, so we're back to doing fractions again. So this is grade 9, grade 7, grade 6, grade 5. We've been doing fractions for a long time. I hope you remember how to do them, but when you're multiplying fractions, there's nothing simpler than multiplying fractions. Just as a side note, let me just erase the bottom. And I'll show you what to do. So instead of a whole number of 2, we're going to write 2 over 1 times our fraction, which is a negative 4 over 5. All we have to do whenever we're multiplying fractions together, we're multiplying numerator by numerator and denominator by denominator. Positive times negative will give us a negative answer. So automatically we're going to put a negative first. 2 times 4 is 8. 1 times 5 is 5. Okay, so that's going to be our answer on the left side of the equation. Let's keep it on the left side of the equation. And then y plus 5. Okay, whenever we have something like this, we probably want to get rid of the denominator. This 5 as a fraction really limits our ability to find the true value of y. The way to do this is, because it's 8 divided by 5, in order to get rid of the 5, we have to do the opposite function. So we have to multiply both sides by the number 5. When we multiply this by 5, we get negative 8. This by 5, and in fact, when we're multiplying by 5, on the right side, we have to multiply everything that's there, the y as well as the number 5. So we're going to get 5y plus 25. Okay, for our next step, we have to get rid of the 25. The 25 comes over and becomes more negative. Okay, negative 8 minus 25. So negative 8 minus 25, we get an even more negative number. So we're going to get negative 33 equals to 5y. 5 times what gives us negative 33? And the answer is, we're going to divide both sides by 5. In this case, once again, it's not a whole number, but rather a fraction. And so our answer will actually stay as a fraction. There's no need to reduce it further. If you can't reduce it, just leave it as a fraction.